Welcome to this tutorial on matrix rank in NumPy. Matrix rank is a fundamental concept in linear algebra that helps us understand the structure and properties of matrices. We'll explore how to calculate it using NumPy's linear algebra module, specifically the matrix_rank function. The rank of a matrix is defined as the maximum number of linearly independent rows or columns. In simpler terms, it tells us how many rows or columns in a matrix are truly unique and cannot be expressed as combinations of other rows or columns. This is a crucial property that reveals important information about the matrix. There are two important classifications for matrix rank. First, a matrix has full rank when its rank equals the smaller of its two dimensions. For an m by n matrix, this means the rank equals the minimum of m and n second. A matrix is rank deficient when its rank is less than the smaller dimension, indicating that some rows or columns are linearly dependent on others. The syntax for calculating matrix rank is straightforward. First, import NumPy as np, then call np.linog.matrix_rank and pass your matrix A as the argument. The function returns an integer representing the rank of the matrix. Let's see a full rank example. We create a 2 by 2 matrix A with values 1, 2 in the first row and 3, 4 in the second row. When we calculate its rank using matrix_rank, we get 2. This means both rows and both columns are linearly independent, so the matrix has full rank. Now for a rank deficient example. Matrix B has values 1, 2 in the first row and 2, 4 in the second row. Notice that the second row is exactly twice the first row. When we calculate the rank, we get 1 instead of 2. This is because the rows are linearly dependent, making the matrix rank deficient. The matrix_rank function accepts two optional parameters. The TOL parameter sets a tolerance threshold below which singular values are considered 0. This is useful for handling numerical precision issues. The hermitian parameter, when set to true, tells NumPy to assume the matrix is hermitian, which allows for faster computation using optimized algorithms. Matrix rank has several practical applications. It's used to detect linear dependence in datasets, helping identify redundant features or variables. It helps determine whether a system of linear equations has a unique solution, infinite solutions, or no solution. And it's essential for assessing whether a matrix is invertible, since only full-rank square matrices have inverses.
If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.